Eastern Front. Winter, 1943. The land is silent except for the crunch of frozen earth under heavy boots. A group of German infantrymen, advancing cautiously through the aftermath of an artillery strike, stopped dead in their tracks. Before them lies a vast open field, covered not in chaos, but in order. Hundreds of craters stretch as far as the eye can see, each one circular, each one perfectly spaced from the next, forming what looks like a mathematical pattern carved into the ground. The soldiers exchange glances, bewildered. To them, artillery was supposed to be random, a storm of destruction, never precision. Yet here, destruction had geometry. Snow dust drifts into the hollows of the craters, softening their edges, but not their perfection. The men walk among them, measuring the distance by foot. Every impact is uniform, 20 meters apart, in all directions. The report that followed would later read simply, "The Soviet barrage displayed unnatural accuracy. Each explosion fell as if plotted by engineers' grid." But how did such mechanical precision come from the chaos of war? To understand that, we must go back to the roots of artillery science and the changing face of modern warfare. In the early years of the Second World War, artillery remained the silent giant of every front. It killed more men than tanks, planes, or rifles combined. Yet, in 1941, when Germany launched Operation Barbarossa, the largest invasion in history, the Wehrmacht's gunners believed they held absolute superiority. Their methods were rooted in efficiency, precise gun crews, rapid calculations, and doctrine that emphasized mobility and coordination with advancing armor. Across the frontier, the Soviet Red Army was still reeling from political purges that had gutted its officer corps. Its artillery doctrine was scattered, communication weak, and coordination often chaotic. When the Germans crossed into Soviet territory on June 22, 1941, they encountered scattered resistance, brave but disorganized. Soviet batteries were often overrun before they could even correct their range. But what the Germans didn't realize was that behind the scenes, the Red Army was quietly studying them. Soviet military engineers began collecting battlefield data, capturing unexploded German shells, and analyzing firing patterns. Within months, teams of mathematicians and physicists, many from Moscow and Leningrad universities, were pulled into military service. Their mission? Transform the chaos of artillery into a science. At this stage, most armies relied on line-of-sight targeting. Forward observers would spot enemy positions, relay coordinates by radio or telephone, and guns would fire in response. But visibility was rarely perfect. Fog, terrain, and smoke constantly obscured targets. So accuracy depended on experience, the human eye, the steady hand, and luck. The Soviets began to change that. In early 1942, a new doctrine emerged under the Artillery Directorate. It was called fire by grid, an approach that treated the battlefield as a vast mathematical plane. Every gun position, every enemy target, every elevation was plotted onto a master coordinate system. Meteorological data, wind direction, temperature, and shell weight were calculated before the first round was even fired. This method was slow at first. Hours of preparation for a few minutes of firing. But its effect was revolutionary. Soviet officers no longer needed to see the target. They needed only its coordinates. When the fire order came, entire batteries, sometimes hundreds of guns, could unleash their shells simultaneously, each one destined for a pre-calculated point. By mid-1942, during the battles near Rzhev and Voronezh, German field commanders began reporting unusual patterns of bombardment. Shells fell with startling regularity. Impacts formed clusters, sometimes perfect rectangles or arcs, shapes too deliberate to be random. Many German observers assumed it was chance, or the product of massive ammunition expenditure. Few realized it was the dawn of computational artillery. The Red Army's investment in scientific warfare deepened. Portable range tables, plotting, templates, and new PAB-2 aiming circles were distributed across divisions. Training manuals emphasized mathematics as much as marksmanship. And behind the front, in the dim light of command posts, teams of artillery officers hunched over graph paper, drawing grid lines, aligning compasses, calculating fire solutions by hand. To the Germans, these were just Soviet quirks. But they were, in fact, the first steps toward a weaponized form of geometry, the ability to design destruction with precision. By late 1942, as the front lines froze once again under the Russian winter, the stage was set for something that would redefine artillery forever. The Red Army was preparing to unleash its new science in full, and the battlefield would soon reveal the terrifying beauty of mathematical firepower. By the beginning of 1943, the transformation of Soviet artillery was complete. What had once been a scattered reactive force was now a coordinated instrument of mathematical precision. Soviet commanders referred to it as artilleriskaya podgotovka, artillery preparation. It was not a barrage in the traditional sense, it was a calculated grid of death. To the untrained eye, a Soviet artillery strike looked chaotic, hundreds of explosions erupting across open terrain. But viewed from the air, especially through reconnaissance photographs, the pattern revealed itself. Impacts were evenly spaced, laid out across square sectors. Each explosion corresponded to a specific point in a firing table, every gun synchronized by clock and map grid. The goal was simple: leave no safe ground. This evolution was driven by desperation and adaptation. The Soviet Union's early defeats had shown the limits of manpower alone. Artillery had to compensate for lack of mobility, and mathematics became its greatest ally. The Artillery Directorate of the Red Army, under Marshal Nikolai Voronov, established centralized fire control centers that coordinated dozens of regiments from a single plan. Voronov's philosophy was that artillery should act like a single weapon, not many guns, but one vast system. Each gun battery became a mathematical unit within that system, contributing to a pre-planned grid that defined how far, how wide, and how deep the destruction would go. The result was an unprecedented level of accuracy. Soviet surveyors measured gun positions with optical theodolites, correcting for Earth's curvature and magnetic deviation. Meteorological balloons provided upper air wind data, allowing ballistic tables to be adjusted in real time. The firing calculations were so detailed that even temperature changes inside the barrels were accounted for. At the same time, a new weapon was added to this symphony of precision: the BM-13 Katyusha, multiple rocket launcher. Unlike traditional guns, the Katyusha fired up to 16 rockets in a single salvo, blanketing entire areas within seconds. When deployed alongside pre-sighted artillery grids, they turned enemy strongpoints into smoldering wastelands. The Germans gave the weapon a name that captured its terror: Stalin Orgel, Stalin's organ. Its howling launch sound echoed across the front, followed by perfectly patterned explosions that no soldier could forget. When combined with pre-registered coordinates, these rocket salvos appeared almost mechanical. Reconnaissance flights would later record entire fields pockmarked with near-identical craters, each one only meters apart. The precision wasn't born from luck. It was the logical result of calculation, synchronization, and the cold discipline of Soviet artillery officers who had turned warfare into geometry. By the time of the Battle of Stalingrad, this system reached maturity. Soviet batteries didn't simply respond to German attacks. They anticipated them. They mapped likely approach routes, measured distances to every crossroads and riverbank, and prepared tables for each. When the Germans moved, shells were already in the air. In the final encirclement of Paulus's Sixth Army, the Red Army used grid bombardments to isolate pockets of resistance. German survivors later described craters forming in perfect alignment, as if the land had been measured and carved by an unseen hand. For many of them, it was the first time artillery felt engineered. This was the psychological effect the Soviets had been cultivating: precision as terror. When randomness disappears from war, fear becomes absolute. As 1943 began, this method was no longer an experiment. It was doctrine. Every major Soviet operation, from Kursk to Operation Bagration, would rely on the concept of coordinated, pre-calculated fire. The perfect craters the German soldiers would later find were not accidents of physics. They were proof of a new kind, of warfare, one born not from chaos, but from mathematics. And at Kursk, that science would be tested on an unprecedented scale. When the first shells landed at Kursk in July 1943, they did not fall randomly. Each impact was the